Hi guys, welcome to lesson 9.2. Today we're going to be factoring out the difference of two perfect squares. So hopefully by now in your math career you understand the word difference means subtraction. And perfect squares are numbers or squares that we have perfect square roots to. So for example, x squared would be a perfect square because x times x equals x squared. Some other examples of perfect squares would be like 4, 2 times 2, 49, 7 times 7, so on and so forth. If you want to, you can Google a list of all perfect squares and their square roots because that will help you out a lot in this lesson. Before we do any examples, I would like you to go ahead and write down either on your paper or in your notebook or whatever you're taking notes on. I want you to go ahead and write down the steps for factoring the difference of two perfect squares. That way, when we're doing examples, you can refer back to it and not have to go back to the timestamp and everything like that. I know these steps might not make sense right now, but trust me, when we start doing the examples, they'll make a lot more sense. So let's go ahead and write down these steps. So factoring the difference of two perfect squares. Step 1 is we're going to factor out any common monomials. And this is what we did in the last lesson. This is what we did in 9.1, finding out if there's anything in common between all of the terms in the equation and factoring out or dividing those out. The second step is we're going to find the square root of both terms. The only way that this method works is if the first term and the second term are both perfect squared, like we talked about, x squared or a variable squared, and then the number at the end is going to be a perfect square. And if you Googled that list of perfect squares and their square roots, that should help you out a lot. Step number 3, use the square roots as binomial terms, and we'll go over that here in a minute. Use the square roots as binomial terms, one with an addition sign and one with a subtraction sign. So with those steps written down, let's go ahead and do example 1. All right, for example 1, we have x squared minus 49. Now this is the difference of two perfect squares because x squared is going to be a perfect square. And if you have that list, you know that 49 is also a perfect square. So let's look at our steps and how to solve this problem. Step number 1, factor out any common monomial. So we have to look, is there anything in common between x squared and 49? Now there's no number I can divide out, even though there is a pretend 1 right here, because if there's not a number in front of our variable, we pretend there's a 1. And yes, 1 can be divided into 49, but 49 divided by 1 is 49. So there's no sense in factoring out 1. So now we have to look, are there any variables that are in common? We have an x squared here, but there's no variable here, so there's no variables that we can factor out either. So that means we have to go on to step 2. There's no common monomial factors to factor out. Let's move on to step 2. Step 2 is find the square root of the first and the last term. So we're gonna find the square root of x squared and the square root of 49. So the square root of x squared, what times itself will get me x squared? X times x will get me to x squared. So the square root of x squared is x. Next, we have to find the square root of 49. What times itself will get me to 49? Now we should know 7 times 7 will get to 49. If not, check out that chart that you hopefully found on Google or wherever to find your perfect squares and their square roots. 7 times 7 is going to be 49, so the square root of 49 is 7. Now we're going to move on to step number 3. Now for step number 3, our answer is going to look like, if you remember back in chapter 8 and when we did the FOIL method, we had 2 parentheses, 2 binomials multiplied together, and we had to do the FOIL method. And even then I told you that in this chapter, we're going to be doing the reverse of that. So our answer is going to look like 2 binomials or 2 parentheses next to each other multiplied together. So it's going to look something like this. We have a parentheses and then a second set of parentheses. And what we're going to use is we're going to take what our answer is, what the square root of each of these is, and that's going to be what's inside of our parentheses. So the first one is going to be x and 7. Second one is x and 7. And then step 3 says one of them has to be addition and one of them has to be subtraction. Now it does not matter which term the first or the second one is adding or subtracting, as long as one is adding and one is subtracting. So I'm gonna do x plus 7 and then x minus 7. Now the way we would check our work here is by doing the FOIL method. That's what we're going to be doing for the rest of this chapter. We're going to be doing the FOIL method to check, and even some of the steps require us to do the FOIL method in order to get the right answer. So let's do the FOIL method. FOIL starts with f, which is the first term. Multiply the first terms together. First term of this one is x times the first term of the second is x. X times x is x squared. Then we're going to find out the outside terms. What are the outside terms of this entire thing? Which is going to be x times negative 7, which is going to be minus 7x. Next is I, FOI. Inside terms, positive 7 times x is going to be plus 7x. And then our last terms of each, which we have positive 7 times negative 7, which is going to be negative 49. Now if we follow our FOIL method steps, now we have to combine like terms to get x squared minus 49, which, if you remember, is our original polynomial or binomial. So we know that our answer of x plus 7 times x minus 7 is the correct answer. Let's try another example really quick. All right, example 2, we have 5a squared minus 125x squared. Now, this one looks a little bit different than our first example, but we can follow the same exact steps and still get our answer. So the first thing we're going to do, step 1, is factor out anything that's in common between all of the terms. So looking at this, let's look at our numbers first. I have 5 and 125. And I know, because this ends in a 5, that 5 can be divided into both of these. So we're at least going to be factoring out 5. Now let's look at our variables. We have a squared and x squared. Now these aren't common. A and x are different numbers, so we can't factor out any of our variables. So after we figured this out, let's divide like we did in 9.1 and then get and then move on to step 2. We have 5 times 5 divided by 5 is 1, so I have a squared minus 125 divided by 5 is 25. I can't cancel out any of the x squared, so I'm just going to bring those down. Now that I have factored out the 5, I'm not going to use it again until I have my final answer. So now I have to look inside of the parentheses because that still has not been factored. So now I have to look inside the parentheses and see and find the square root of both of these numbers. So I'm going to find the square root of a squared and the square root of 25x squared. Now the square root of a squared is going to be a times a. So the square root is a. The square root of 25x squared. Now let's look. We first need to find out the square root of 25. Now if you have your list or if you know off the top of your head, the square root of 25 is going to be 5. Next we have to look at the variables. What is the square root of x squared? Which that would be x times x is x squared, so the square root of x squared is x. Now we have our two terms that we need for inside of the binomial. So to write our final answer, we cannot forget about this 5. So we're going to start our answer with 5. And then we're going to start our parentheses. And we're going to use these two terms. Now I'm going to use addition for the first term because remember, one of the binomials have to be adding, one of the binomials have to be subtracting. So I just always start with adding. You can start with either one as long as you have one of each. So this first one's going to be a plus 5x, and then we're going to start our second parentheses. A minus 5x. Now the way we would check our work here is we would first do the FOIL method here, and then we would do distributive property with the 5. So let's go ahead and try that out really quick. So ignoring the 5 and just doing the FOIL method, we're going to first multiply the first terms of each binomial, which would be a times a to get a squared. Next, we're going to multiply the outside terms of each, or of the whole entire thing. So we have a times negative 5x to get minus 5ax. Then we're going to multiply the inside terms of the entire thing, which would be 5x and a, to get plus 5ax. And then multiply the last terms of each. Positive 5x minus 5x to get negative 25x squared. Now that I have that, let's combine our like terms to get a squared. 5ax plus 5ax cancels out, minus 25x squared. But now we can't forget about this 5 because this is not our original equation, okay? Now we bring down this 5, and now we would multiply. 5 times a squared would be 5a squared. 5 times 25 would be minus 125. And then we bring down our x squared. 5ax, 5a squared minus 125x squared is our original problem. So we know that our answer of 5 times a plus 5x times a minus 5x is the correct answer. Let's do one more example and then you can get started on your lesson. All right, example 3, we have 1 minus 64y squared. So step number 1, check to see if there's anything in common between the terms or factor out the common monomial. We have 1 and 64. Yes, 1's in common. Let's not worry about factoring out where you just get the same thing. And then we have 0 variables, and then we have y squared. So there's nothing we can factor out, which I like these a lot more because it saves us a lot of time. So moving on to step number 2, find the square root of both terms. So we're going to find the square root of 1 and then the square root of 64y squared. Now to find the square root of 1, what times itself will get us 1? And the answer is 1. 1 times 1 will get us 1. So we have 1, then the square root of 64y squared. And just like the last example, let's first look at the number and then look at the variable. What times itself will get us to 64? 8 times 8 is 64, so I know that the number is 8. And then what times itself will get me to y squared? Y times y will be y squared. So we have 8y. Now we're going to use both of these just like we have in example 1 and in example 2 for the terms of our binomials. So I'm going to start my parentheses. I'm going to use 1. And then, like I said, I do addition first. It doesn't matter. 1 plus, then I'm using the 8y, times, then I'm going to use subtraction. Same two terms, but with subtraction. 1 minus 8y. Now, if I was to check my work, and I'm going to check it up here, to check our work, use the FOIL method. To check our work, we're going to use the FOIL method. And so we're going to first multiply the first terms of each. 1 times 1 is 1. Now the outside terms of both, 1 times negative 8 is minus 8y. Inside terms, 8y plus or times positive 1 would be plus 8y. And then the last terms of each. 8y times negative 8y would be minus 64y squared. Don't judge my little squared. Combine our like terms. 1, these cancel out. 8y, negative 8y plus 8y cancels out. Minus 64y squared is the same as our original problem. So we know our answer of 1 plus 8y times 1 minus 8y is the correct answer. That's going to wrap up all of our examples for 9.2. So if you have that assignment sheet that I sent your parents, go ahead and do those numbers, and I will see you in 9.3. All right, that's going to do it for today's lesson. I hope you fully understood everything that we were going over today. If not, that's okay. Please feel free to reach out to me. If you don't already have my contact information, your parents should, so go ahead and get that from them. And if I can't help you out either over the phone or through text or FaceTime or anything like that, and you want to meet up here at the school one-on-one, that's fine with me. Just have your parents contact me first and make an appointment so that way we're here at the same time. I wish you good luck on your lesson, and I'll see you next time.